fear it. If you missed yesterday, there's a video that goes along with it, obviously. So please watch it, and it'll help you out learning these calculators. And the thing is, if you have not gotten one of these calculators, I strongly encourage it because it's going to be used throughout high school. And it's something that could be used throughout college as well. And it's just a really valuable tool for our students to use. So if you have yours, get it out, please. If you need one, I have a few you could borrow over here. So don't always rely that I will have them borrow. Oh, can I have water?
I don't even have a digital one. Mine's like 1998 calculators.
Okay, so guys and girls, realize those of you who grabbed one of the requirements for this class is a graphing calculator. Don't tell me you can't afford it when you're walking around with an iPhone 6 or 7 or whatever. Any of you that are paying some data plan of $60 a month for your data plan, you need to have a calculator. Okay? If you don't have one, get one. There's no excuse. I honestly feel like just saying, you know what, go put those back, and I'm going to show you how to do this, and you're expected to do this on a test, whether you have it or not. It's absolutely ridiculous. Absolutely ridiculous. Get the calculator. All right, let's take a look at this. So I'm going to go in each and every time we use the calculator, and I'm going to go through the exact same routine to make sure things are ready to use. Why is that? Because there's things that the calculators could be turned on that don't need to be turned on, or are turned on and will make things goofy on your graph. So first thing is, everyone figured out how to turn their calculator on?
Yes.
Good. All right, let's see if we can get this. Is this going to work? So first thing, let's see, that works for me. Not sure if my fingers are going to work. So that'll work. All right. So go into y equals once you turn your calculator on. If there's anything in any of those, now realize my arrow keys, there's more than just 9 graphs. It looks like it goes up to 10 graphs. Yours might look a little different than mine, but for the most part, the operating system is the same. It doesn't matter what colors you're using. It's not vital for you. A color does not change anything about how things are graphed. Okay, so don't get hung up on, oh, well, I want purple. Just graph it. Okay? So if there's nothing in there, use your arrow keys going up and down. And that's after you hit y equals. Okay? I'm going to go into hit the second button, y equals, and we want to make sure our plot 1 is on. If it's not on, let's turn it on. So I'm going to pretend mine is not on. So I'm going to hit number 1. I want my cursor to be blinking where it's on. If the off is there right now, use your arrow keys. And your arrow keys will work pretty nicely. Which are these? Go through. And you want to have that very first graph on. This is the scatter plot. So this means it's a scatter plot. It means it's going to plot points. This means it's going to plot points and connect them. You don't want that. okay? This is a bar graph, box and whiskers, and then a step function, okay? You don't want it. You want it to be a scatter plot. You want list 1, list 2 to work, okay? Don't get hung up on your mark going, oh, I like a dot, okay? Don't make your color yellow or something's going to be hard to see, okay? Don't make it clear. Okay, looking at our first word problem, okay? This talks about cumulative GPA. You on that side of your paper?
Yeah.
So let's go through the word problem and talk about what it means. The table below shows the correlation between a student's high school cumulative GPAs and their predicted future starting incomes. Okay? So GPA of 0 all the way up to a GPA of 4. So someone who's got straight Fs versus someone who's got straight As. And then for somehow they figured out, they collected this data somehow. I'm not saying it's true or false or indifferent. I'm just saying we have data we're looking at and we're going to utilize. Okay, so this is the same thing we were doing. You could go and create your own scatter plot, do it by hand, where your X value is going to be your GPA and your annual salary is going to be your Y values. Your cumulative GPA is going to be your input. Your salary is going to be your output. Your independent variable is your GPA. Your dependent value is your salary. So using a graphing calculator, let's find the line of best fit. Okay? Same first, that works. All right, so has everyone gotten to this point? Does everyone feel comfortable here?
Yes.
Okay, now if you're off in another place that's screwing around your calculator, I'm not waiting for you. Let's follow along, let's figure this out. Once we're here, I'm going to go to second. We're going to go to second and then mode. So it's going to quit out of there. Now you might have something on your screen, which is fine. But let's just get out of there. Everyone here? All right. From there, we're going to hit stat. It's this button right here by the arrows. Get to that screen. You there? Okay, we're going to go stat edit, which is number 1. You might have stuff in list 1. You might have stuff in list 2. We worked with these yesterday. This is how you clear it. Don't act like you know what to do, because if you do, you're going to clear out the L1 itself. So you're going to use your arrow key. You're going to go to the top with your arrow key of L1. You're going to hit, hang on before you hit anything, you're going to hit clear. Clear is not the same button as delete. So if you hit clear when you're up there and then hit the down arrow, it's going to take everything out of the row. Everyone find that? Then you can use your arrow key, go back up to the top, go to the top of L2, hit clear again, and push down arrow. And now your lists are gone. If you hit delete, L1 is now gone.
Forever?
Did you hit it?
No, I didn't.
Then don't worry about it. Don't ever hit it though. Okay? You have to reset the calculator and put it back in. Okay? I'm not quite sure why TI felt that this was a good idea, but they did. Got it? All right, so our list 1 is the cumulative GPA. So using your arrow keys and your numbers, you're going to plug your data in. What you might notice is if you're trying to put 0.0 in, it just defaults as 0. You put 1.0 in, it defaults to 1. That's okay. You didn't do something wrong. So what do you think I'm going to do for list 2? Put in the annual salary, yeah. So using your arrows, once you get there. So if you made a mistake, like let's say you put like 14,000 in here, and that's wrong, just go use your arrow key, go back up above it, and type in the correct amount. So a few things to know about this calculator. If you start getting to a point on your list where your numbers are very spread out, it will automatically default it into scientific notation. It's fine. It's the calculator's operating system to do. Okay? So, list 1, comma, list 2, that's x, comma, y. So 0, comma, 11,500 is one of your points. 0.5, comma, 15,500 is another one of your points, and so on and so forth. Those are all your x and y values. Those are your points that you're going to plot. This is how the calculator puts it into the operating system. So here's the nice thing. Raise your hand if you had information when you first got to the list that was in the lists. You had stuff there, you had stuff there, stuff there. Cool. Here's the nice thing. It stays in the list until your batteries die, you clear it out, or you reset it. Okay? So the nice thing is, if you get off this screen, you don't have to go back and plug your data back in. It's sitting in the spreadsheet. Okay? So if you go to your calculator and you hit second and then mode, which quits out, our data is still sitting there. It's not like, oh, it's gone now. It's not like you hit, delete and it was gone. Okay? So, using the graphing calculator, find the equation of the line of best fit. Before I do that, I want to do this. Let's hit y equals, upper left-hand corner. If there's anything there, clear it out. We already did this, but I just want to make sure. Let's clear it out. Everyone good? Okay, so what you're going to hit now is you're going to hit the zoom button. It's the top button in the middle. And we're going to hit zoom stat, which is number 9. You can either go down to it and hit enter, or you could go on there. But you should start seeing something on your calculator that represents that. Now, you might have used the little pluses. You might hit the other stuff. Your data doesn't match. You did something goofy. 0.5, 1.52, 2.53, 3.54. Okay. Tell me what your other stuff is. Gotcha. Yep. 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 Oh, you forgot that. Everyone get something? Got it?
Oh.
What's that?
Plug it in.
I like that. You got it.
Plug it in.
Oh, you know what happened? One of your data. So I'm going to do this. I'm going to stat, edit. Okay, one of those was wrong. So read me wrong. 11.5. What's that one?
Oh.
So 3250. But this one has some pretty good ideas. Good job. Get it? Your rows are not. So you have 0, 1.5. You forgot 1.5. So it's 1.523,000. That's just right. Second insert. Is this yours? I say charge it. Yours.
Same.
Gentry, stop flirting with David.
Shut up, Joseph.
Go across. 20,000. Regular, 20,000. 23,000, okay.
Because she's like,
What's after 23,000?
she got a 650.
3,000, hang on.
Oh my God. Look at this dude.
33,700.
Joseph's forehead.
What's up? 38,000.
What'd you say, Rob?
That's the.
Bro.
Don't talk to me like that.
Bro, the joke.
Okay.
Thank you, Chris. There we go. There we go.
All right. Hey, so went around, looked like about everybody was good. Okay, I saw a lot of people with stuff on their screens. Okay, so is that the line of best fit?
No.
No, that's just the data plotted, right? And so if we had our, if this was our paper, we would have to, match in a line of best fit that works. But the calculator is going to do it for us. Okay, we're going to find the equation that's going to work. You ready? I got to go slow. There's a lot of button strokes. Why does somebody else have your calculator? Why? Like, what's on your calculator? Can I see? You have your stuff? Which one of you type this? Suck my nuts? Really? Like, someone type this. This is the default on the calculator. Whose calculator is this? Is this yours? stuff go out the hall. This is your calculator, right? Yeah? Okay. I'm going to take a screenshot of it. It's going to be sent to your dean and to your parents. Who did? It wasn't me. Okay, but it's your calculator. Brand spanking new things we're working on. Okay? Figure out how to act in school. Okay? Did you type it? Take your stuff, go with them. Sit out in the hall. I'm going to send you to your deans. Anybody else need to join them? So I'm trying to teach a new concept, brand spanking new. Everyone else ready to learn? Yeah. Apparently there was a couple that didn't. So sorry about that, everybody. All right. So everyone's here. Are we here still? Okay. Okay. Oh, we need to find the line of best fit. The calculator will do that for us, which is pretty cool. Okay? So I'm going to go back and I'm going to hit the stat button. Not going any further than that. Is everybody there with me? Okay? You're going to go use your arrow key and arrow over to calculate. And there's a lot of different regression equations that exist. Okay? Ours looked like it was going to be a straight line. Agreed? Yeah. So would linear regression make sense? Yes. Now notice number 4 says lin reg. And then it says ax plus b. We're used to it as mx plus b, right? So do you think the slope, they're using a versus m?
Yeah.
Yeah. Okay? It is what it is, but that's the only thing. So I'm going to use my arrow key to go down to it. I'm going to hit enter. And some of yours might, depending upon which one you have, might look a smidge different. Okay? But what you want is you want your X list to be list 1, your Y list to be list 2. The other things aren't all that important for you. That's the main important thing. So arrow down once you get there to calculate and hit enter. This is the linear regression equation that will match up with our data. As far as this is our line of best fit. This is doing, rather than me going, oh, I have y-intercept and I have another point. Okay, I need to find the slope. Okay, I need to plug the slope and the b value back in. This did it for us. So right here is my slope, 74.75. My y-intercept, $11,744.44. Remember yesterday we talked about sometimes when you do those predictions, you're off a little bit. Your calculator's saying, hey, there's this linear function that exists. Okay? This is telling us, hey, this is the equation that works. Okay? Our data told us our y-intercept is 0, 11,500. Our line of best fit, because the calculator is trying to get it to match up. Right? Calculator's trying to get it to match up. So what it's doing, it's doing this. Okay, if the calculator's doing this, getting the line of best fit, that means that if it plugs in, our y value is not going to be exact, and that's okay. There's a margin of error that does indeed take place from data to applied, and that's okay. Okay, this line of best fit we can graph right on top of ours. This is how we do it. You ready? This is going to be a lot more keystrokes. First key you want to hit. With us?
was there, then I pressed like right on the.
Oh, I see what you're doing. Very good, right? So we're going to hit y equals upper left-hand corner. Y1's going to be blinking. Again, color isn't really all that important. Okay, so some of you get the choice of colors. Great. Some of you just get the green and black lines. Okay? So this is where it's going to get goofy. So this is telling the calculator, hey, I want to find an equation. I want to put it there. Find the vars button. V-A-R-S. It's underneath the arrows. Hit enter. Good? Go to statistics, which is number 5. Hit enter. Okay? Go over to equation. And we want the regression equation, which is number 1. So hit 1, enter. There it goes. And it's going to plot it there. And then once you do that, you can hit graph. Let's see how you guys are at.
The second point's an outlier.
Yeah, that's it. Get it. Oh, no.
No, I don't.
So when you go bars, statistics, equation. That's kind of cool.
It's actually pretty cool. Is yours black and white? Here.
Bars, statistics, equation.
Look at revision. I don't know what plus.
Alright, so, pretty cool?
Yep.
This is pretty easy. This is our line of best fit. So let's take a look. It says, identify and interpret the correlation coefficient. Okay, we're not there. We're not there yet. There is something on our calculator we can turn on, which it's r and r squared. And r and r squared just mean how much in the 1 dimension are they equal and how much in the 2 dimension are they equal. And the closer they are to 1.00, the better it is. I would say that our r squared value here is about 0.9996, which means the calculator is 99.99% or 96% sure this is the right line that fits with this data, which is kind of cool. If you got a 99.9% on a test, aren't you like, yeah, sweet?
Wait, on test, do you round up or round down?
I'm not, dude, I'm not rounding out anything, man. I'm just saying. If you were to go to the doctor and the doctor says, look, you have a 99.96% chance of surviving the surgery that you need, you're probably going to say, dude, I feel pretty good about this. If the doctor says you have a 99.96% chance of dying, you might say, you know what? Let's hold off on that. Right? So no, I'm not going to round up. I don't round up. I don't give you a score that you didn't earn. So But Rom, you have an A in here, so you're good. Because of the last test, you did really well. Brought you up. I like it.
Funny.
So you are earned an A with me. There's no rounding that needs to take place because your A is really an A, and it's not some, buttered up, fictitious. Oh, he was a nice kid.
Yeah, can you give me that
No.
acceptance thing?
No. All right.
I want to do accept.
So what else do we have on this sheet? So let's not worry about the correlation. Interpret the slope of the linear regression in the context. Okay? So I don't want you to all do this. I'm just going to go back. I want to look at what our linear equation is. Don't do this.
Can we clear this?
No, just keep it there. Our slope is this. Our slope is this. Okay? Which means for every, we will earn $7,475 more dollars for every increased letter grade. So from a 1.0 to a 2.0, from a 2.0 to a 3.0, a 3.0 to a 4.0. Okay? Can we get above a 4.0? It depends if the school observes weighted grades. This school does for AP. Okay, but not all schools do that. Sometimes that becomes a weird thing for colleges because some schools, kids have taken AP or IB classes that weren't weighted and they're 4.0, and then someone from Cherry Creek High School that's taken AP as like a 4.7. They have to understand that some schools won't weight it, some schools do.
Wait,
What's the right thing?
Does Cherry Creek weight
Yeah.
honors classes?
AP. Is it honors as well?
I'm pretty
Yeah.
sure it's honors.
Sounds good. Interpret the y-intercept of the linear regression. Well, the y-intercept is this. So that means that if you got no credit in high school, our model says you should make this much money a year.
In a year?
I think that's what it's for.
Yep.
Predicted future starting incomes. So your income for a year. Annual salary. Yep. So that's how much you're expected. If you failed everything in high school, that's below minimum wage, folks. Well, that's the tough thing. And you know what? Everybody has an uncle or a brother or a cousin or a nephew or a best friend that. And that shouldn't be how you're living your life. Okay? One of my best friends in the entire world, his name's Bill Ebright. Dropped out of high school when we were 16. He is a multimillionaire.
Actually?
Is that the model that I should be going with? No, because I have other friends that dropped out of high school that live in their car.
How did he get rich?
How is he multi?
He married a girl who,
Oh my god.
just saying. I'm just saying. I mean, so what did he do? He married a gal out in California whose family owns a construction business. So he works for this company. He started out driving a water truck, the truck that splashes water on the dirt. And now he's moved on up the ranks and has bought pieces of heavy machinery. Okay, he's doing quite well for himself. Is that the business model we should focus on? Going, because Chris Stirrup has a friend named Bill Ebright who dropped out of high school. That must be the model to go with? No, he beat the odds.
He was in the hospital.
And the sad thing is, like, dude, he doesn't even have a high school diploma. I have 4 degrees beyond where he has. And I'm not a multimillionaire. I'm a billionaire. No, I'm kidding. I'm just kidding. Maybe if I took the decimals off the pennies or something, I don't know. All right, so what other things do we want to know about this? Interpret the y-intercept we did. Use your equation to approximate the average starting salary of a student who has a 3.2 GPA. Okay, so I'm going back to my graph. Okay, you guys all still there? So we want a 3.2 GPA. So 1.0, 2.0, 3.0, 4.0. So we're looking about right here, how much is this person expected to make roughly? Okay, I don't have things really labeled, but the calculator will do the work. Do people usually come out with a 2.0 or a 3.0 exactly. No, it's usually above that. So let's figure out what if someone expected earnings if someone had a 3.2. Okay, ready? Ready? Is everyone still here?
Yep.
Everyone still looking at their line?
Yep.
You ready?
Yeah.
Okay, I'm going to go second. And then find the trace buttons at the very top. So we're going to go second, calculate. Okay, second, calculate. We are going to find a value, so number 1. And we want to plug in the 3.2. Hit enter. The person who has a 3.2 GPA, starting income is expected to be $35,664.44.
Wait, how do you do the Y then?
I'm not there yet. I'll get there.
Did you know that trash truck drivers like make like $50,000?
Yeah.
I did not realize.
They make
that.
what?
That's so crazy.
They make a, but I can discuss with you. It's actually an inflated amount.
Oh, it is. Okay.
I can tell you how it works. Okay, so that is a great question. So the question was, could I just scroll over? Because notice the cursor. If I start using my arrow keys on my cursor, it works pretty well. But notice how far out that is. So we wanted to get to an exact value of 3.2. So yes, you could get to a pretty good approximation of a 3.2. 330. So mine came out pretty close there. Now, how do I know I'm exactly on my line? It looks like it. But again, one more? But again, how are you going to make sure you're exactly on your line? The best way to do it, honestly, is to calculate. If you calculate it, it's going to do this. This does not necessarily mean it's sitting on the line. It might be close, but it doesn't have to mean it's exactly. Okay, so this value here is the point, 3.2, comma 35721.463. That doesn't mean it has to be on there. It might be close. It doesn't have to be exactly. Okay, so please don't do that. I think for approximation, you're fine doing that.
Wait, I put in the value for.
Yes, I would.
I put in the value for this, and it came out to 2.664.
So I bet you one of your data points was off a smidge. You might have forgot to put 250 in at the very end, 35,250 or something like that, and that'd be the only reason why. Okay. Now the question was, how do you plug in the Y value? Okay. I hope to one day have a starting salary of at least 40,000. What GPA am I adding? Am I aiming for? Okay. So I'm going to do this first. Is it possible that I might have something that doesn't fall on my graph? So what I want to do is I'm going to go to Zoom, Out, Enter. And that's going to be, so anything inside of our data is called interpolation. Anything outside of our data is called extrapolation. So we're making an outside prediction.
I have to press enter again.
Did you hit enter?
Oh,
Thanks.
No, you have to press enter again.
you have to press enter twice
Now.
to see it.
Enter. One more time.
Wait, aren't we interpolating though? Why do we need to?
We might be interpolating, but I just want to make sure we had enough room. Now, 40,000 is that what they're asking for?
Yes.
So we have some value here that we want to figure out what our GPA should be. Okay, so we have some value here that we're going to come down and look at what our GPA should be. So there isn't a Y command to do that, so I want to create a horizontal line at 40,000. So I'm going to go back into Y equals, plug in 40,000. Okay? Y equals 40,000 is a horizontal line, doesn't have a slope, it has a slope of 0. And if I hit graph once I do that, lo and behold, I have two lines up there. They happen to intersect each other, agreed? And if they intersect each other, if I find the intersection point, that would tell me what my GPA would have to do. So we could do it by hand, or we could say calculator. We could zoom in. I like it. Okay, if you could zoom in a whole bunch of times, you might be able to get there. Or you could do this. Second, calculate. I want to find the intersection.
It's right above.
First curve, second curve. Guess? No. So if you want to have a starting income of 40,000, you want to shoot to get about a 3.8 GPA, 3.78 GPA.
Pretty high over.
First curve is 3.2.
Yeah, I got that too.
Huh?
It says first curve. And then-
Enter.
Oh,
Second curve, enter. Guess? No. Enter.
thank you.
Okay, got it.
Yep. So you might be you're off a smidge. Now here's why some of the calculators might not be at exactly 40,000. Okay. There's something on each and every calculator, and it's different on every calculator in here. Every calculator is a little tiny bit different. Every one of them is a little tiny bit different. And it's called the tolerance. So what happens is each one of these pixels on this screen are actually little tiny rectangles. They're not little tiny squares. And depending on how the calculator was calibrated, it might be off a tiny bit. And I know that. And that means that if someone gave me an answer here of $39,996.47 or whatever, that might be okay. Okay? Or if this was off just a smidge, that's okay, because the tolerance level on a calculator is off a little tiny bit. Okay? Using your equation, we got that. 3.2, 40,000. Determine a feasible domain for following statistics. Is the data discrete or continuous? Okay? So what do you think my domain should be? Those are my x values. My x values are my GPA. What would be a good region? Should we go into negative numbers?
No.
No. Should we start at 0? Is it possible someone's a ding-dong and didn't pass a thing in high school? Sure. And it's a waste of time, but hey. So we should go from a 0 to a 5 or a 6 might be okay. What do you think the highest GPA could be? If everything was a weighted grade, 5.0 could be the highest. So between 0 and 5 could be a feasible region. If you chose 0 and 6, you'd be fine. Okay? 0 to infinity. If I came way out here to infinity, is the data way out here going to mean anything?
No.
I mean, is it possible you get someone that comes out of high school and you don't know what their GPA is, and then all of a sudden they're making $300 million a year? I mean, I know it's not as likely as you would like. I mean, granted, we'd all love to be that person, but hey, that person's GPA probably doesn't equate to this. Okay? Is this a real-life interpretation? It's data that was observed somehow and collected. It created a linear regression. Okay? Now, here's the thing. It's not only linear regressions that work. Quadratic regressions work. Okay? Quadratic is a parabola. Third-degree polynomial regressions work. Sine regressions work. There's all kinds of mathematical regressions that work, and by doing this, you're able to say, can I make a prediction about some event? And the answer is yes. Okay? Is it always correct? No. Okay? Do you think if you were working in the business world and you were able to collect a lot of data towards a lot of information and say, let's apply this to, if you're off a little bit, you think that's probably okay? Sure, as long as you can back it up saying, this is what my model shows. It shows this. And this is the prediction we made. Now, one person in a company isn't going to be the person that, someone it's called actuarial science. Is this kind of math? They're statisticians. They make a lot of money because they're able to make some predictions for companies. These companies then are able to make higher profits because of the predictions made. Are actuarial scientists always correct? They might be off a little bit. Large companies have a team of people. Okay? So, if you borrowed one of my calculators, can you put it back in the charging station the correct way? Don't force it if it doesn't go. You just put it in the right way. And I would say you guys are going to have an awesome weekend because I'm not going to assign anything. If you have a graphing calculator, bring it.